Okay, so today we're going to review Chapter 1 in preparation for our test on quadratics. So two of the types or forms of quadratics that we had gone over with reference to graphing were vertex form, which we can see right here, and this vertex form here. So vertex form is nice because the vertex is given to you right in the formula. So x minus the h, so in this case our h would have to be -4, and the k is that number subtracting at the end. So the axis of symmetry would be x equals -4 because it's always whatever that first value of the vertex is. And because of our a value here being positive, we know that this graph is going to open up and it's going to have a minimum value, and that minimum would be y equals -3. Additionally, we could then graph this -4 and -3. Our axis of symmetry would come down here. And the little kind of shortcut method that we had done for plotting the other points to get that parabola to emerge was your a times 135, which in this case would be 2 times 135, which would give us 2, 6, and 10. So remember, those act as our rises. So up 2 over 1, then rise up 6 over 1. If you had room, you would go up 10 and over 1. Same thing on the other side. And then you can see the parabola. Now, once you have your parabola graphed, you can see if there's any x-intercepts. In this particular graph, there is an x-intercept here and here, though they don't fall on exact integers, so they would be some sort of a decimal or fraction answer. If you needed to know exactly what those were, you could use your graphing calculator, or you could use quadratic formula or some other method like that, completing a square, something like that. Okay, so moving on to the next example. This one is in intercept form. It's sometimes also referred to as the factored form. Now, in order to get the x's here, you can either use zero product property and solve for your x's, and then you would know they are 1 and 3. Or if you remember the actual form here, it was x minus p and x minus q, and that p and that q, which are 1 and 3, are your x-intercepts. So now if we plot those x-intercepts, we can also find the vertex because we know the axis of symmetry is going to be exactly halfway between those two x-intercepts, and the x value of the vertex will fall on that line. So we do p plus q over 2, which is really just averaging out those two x-intercepts, and we would then get a 2. Now, to get the second part of the vertex, you would then plug in that 2 in for each of these x's in the original equation here. 2 minus 1 is 1. 2 minus 3 is -1. And when you multiply that out, you get +1, which would be your y value of the vertex. So over 2 up 1. Then if you wanted to get more points on your graphing pattern, you would have -1 times 135, which is -1, -3, -5, which obviously shows you that you are going to have a parabola that opens down. And that would mean that your vertex then contains a maximum value, which would be this y equals 1. So that would be your maximum value, and your axis of symmetry would be x equals 2. Okay, so then we go into factoring. So factoring, if there is no coefficient in front of the x squared, you're going to just use simple factoring, breaking apart your x squared into x and x. And then you're looking for those two numbers, then multiply to get 72, that add up to get 22. And because it's a -22, they're both going to be a negative. And those two numbers are 18 and 4. Now for number 4, however, this one is going to be a little different because we have that coefficient in the front. So this is where we have to use that AC method, where we multiply the A and the C and we get the number -12. So then the two numbers that multiply to get negative 12 and subtract to get this middle number here, which is negative 1, would be positive 3 and negative 4, or 3 minus 4. So then we would rewrite this 3x squared, that middle term broken down into two separate x's with the two coefficients that we came up with over here. So you have positive 3x and minus 4x and minus 4. Then you're grouping this. You're now factoring by grouping. When you group the first two terms, you're going to take out your GCF, which is 3x, and you're left with x plus 1. When you take out your GCF on the second side, make sure that sign that's in front of that third term goes with it. So it'd be negative 4, and then you're left with x plus 1. So then your final two factors here would be 3x minus 4, which is the two GCFs put together, and x plus 1. Okay, so simplifying the radical expression, this is where we want to kind of use that little factor tree to break down our radical. So I can think that 36 and 3 goes into 108. 36 further goes into 6 and 6, which you could then continue and do 2 and 3 and 3 and 2. Either way, pair of 3s, pair of 2s, or you could have just said there's a pair of 6s. That 6 is going to come out. There's that extra 3 left inside, but we have to remember that there was already a 3 in the front, so that's going to get multiplied to whatever number we took out, which in this case was a 6. So we have 18, radical 3. Now for number 6, this one is a quotient. So first I would look to see, can I simplify this? But 27 over 49 does not simplify, so I'm going to separate them and simplify them individually. Now 49 is a perfect square, so it's simply going to just be 7. And 27, you can use your little factor tree to break that down and simplify it into 3 radical 3. And the 3 and the 7 are both outside the radical, but they do not reduce or simplify any further. Okay, so now we're going to solve some equations using the square root method. So for instance, if I am going to solve number 7, my goal is to get this m squared by itself. So I'm going to add my 13 to the other side. Negative 3m squared equals 72. Divide by the negative 3, which gives me negative 24. So now I'm going to square root. Remember, every time you square root something, you have a positive and a negative answer. And then to simplify that 24, you can break it down however you'd like, but I'm going to end up with 2 radical 6. And that would be great, except we do have a negative on that 24, so that means you also have to take out an I for that negative. Okay, so number 8. On number 8, we want to get this whole binomial squared alone. That way we don't have to FOIL anything or distribute anything. So if we can get this alone, then we can just use the square root method to solve it, which is much easier. So I have negative 1/4 times m minus 8 squared. And on the other side, I have 7. Now I'm going to multiply both sides by the reciprocal, which would be negative 4 over 1. So that leaves me with m minus 8 squared, and on this side, negative 28. So now I'm going to square root both of those, and that leaves me with m minus 8 squared. Oops, sorry. Obviously, if we square root it, that is no longer there, just m minus 8. And on the other side, I have positive or negative. I'm going to break down that 28 to simplify it. So that would be 2 radical 7. And of course, that negative means I take out an I as well. Now at this point, I'm almost done, but not quite, because I still have this 8 on the same side of the equal sign as the m. So I'm going to add that over to the other side. Just make sure you put it in the front. So it'll be 8 plus or minus 2i radical 7. Okay. So as far as plotting points are concerned with the complex plane, remember that our standard form for a complex number is a plus bi. And so the real number, or the a, will become your x-coordinate, and the imaginary number, or the b, is your y-coordinate. So for a here, this would just be 2, -3. So we would plot that by going over 2 and down 3. Now the next one, we have 4i minus 1. So the real number is actually -1, and the imaginary number is actually 4. So it'd be -1, 4. Just be careful if you're not paying close attention, you might accidentally do 4 and -1. The next one does not have a real number present, so that would mean it's 0, so 0, 2. And finally, the last one here would be -2 and -1. Okay, finding the absolute value. So our formula for absolute value is a squared plus b squared. And again, we're dealing with that complex number in standard form. So in this case, my a is 4 and my b is 8. Even if you say it's -8, it's not going to matter, because when you square a number, whether the original number was positive or negative, it's still going to be positive. So we have the square root of 16 plus 64, which works out to be 80. And then if you want to simplify this, you end up with a pair of 4s. So you have a 4 coming out, and then that single 5 staying in. And because it's absolute value, which is distance, we do not need a negative version of that answer. Okay, so writing the expression as a complex number in standard form. So for number 11 here, we're really going to have to write this binomial 2 times. And then you would distribute, or FOIL as they say, to kind of work this all out and find the product here. So 15 times 15 is 225. Then we have minus 120i and another minus 120i. And then when you do the -8 times the -8, you get positive 64, and this time it's I squared. Now, when you have an I squared, that's going to get replaced with the -1. So then I'm going to have 225 minus 240i, because those are like terms that are getting combined. And then I have 64 times -1. So 225, this will become minus 64 minus 240i. And those two like terms there will give me, I believe it is, wait, it's 161 minus 240i. Okay, so similar type of problem for number 12. We have the foiling that we're going to do with the first two parentheses, and then we also have to consider this -I that's going to get distributed to the second portion there. And then we're going to combine a lot of like terms. So 5 times 2i is 10i. 5 times -9 is -45. I times 2i is 2i squared, and I times -9 is -I. Then I also have -7i and -3i squared. So this is where you'd want to start combining some like terms. Now, as far as constants go, I just have this -45 so far. But then I have 10i minus 9i minus 7i, which are all like terms. So when I combine those, I get -6i. And then I have 2i squared minus 3i squared, which gives me -I squared, which, if you remember, I squared is really equal to -1. When you subtract a negative, you really are adding. So -45 plus 1 would be -44, and then we have our minus 6i. Okay, so finally for number 13, this time we're dividing complex numbers. So in order to divide a complex number, since the rule is that you cannot have an I in the denominator, you would need to multiply by the complex conjugate in order to get the i's to cancel. So in this case, the complex conjugate would be 1 minus I. And whatever you multiply in the bottom, you're also going to do on the top. Oops. Doesn't want to stay there. Oh my goodness, so crazy. Okay, so I'm just going to start writing then. Okay, so when I do the top, 3 minus 3I minus 4I, and then plus 4I squared. On the bottom, I have 1 minus I plus I and minus I squared. So the whole purpose of doing that is because these two i's on the bottom will cancel. And now this I squared, whoops, this I squared here and this one here will both be changed over to negative 1. So on the top, I have 3 minus 7I plus 4 times negative 1. In the bottom, I have 1 minus negative 1. So of course, on the top, I have 3 minus 7I minus 4. On the bottom, I have 1 plus 1. And then that will give me negative 1 minus 7I over 2. Okay. So now we're going to move on to review some completing the square. So solve the equation by completing the square. So when we're completing the square, our goal is to get a perfect square trinomial that we can easily factor into the square of a binomial. So first thing I want to do is figure out, well, what does this third term here have to be so that I can factor that trinomial into the square of a binomial? So in order for me to do this, I need to divide my b term, or that middle term, by 2. So negative 12 divided by 2 would be negative 6. And I square it, and I get positive 36. And that's the number that will make this factorable into the square of a binomial. So now I can factor this into x minus 6 and x minus 6, which is just written as x minus 6 squared. On the other side, I combine my like terms, and I get 8. Now I can simply solve by square rooting both sides. So I get x minus 6 equals positive or negative, and the 8 will simplify to 2 radical 2 if you use your factor tree method. Then last thing to do is get the x by itself. So I'm going to add my 6 to the other side. I have 6 plus or minus 2 radical 2. Okay, so now on the next one, my equal signs over here, right? The problem is half of 20 is 10, and 10 squared is 100, not 104. So we just need to move that over and make room for the 100 that I want to be my third term. And of course, if you add it to one side, you need to add it to the other as well. So now that this is a perfect square trinomial, I can factor it into x plus 10 squared. And on the other side, my like terms give me negative 4. Now I can square root both sides. I have x plus 10 equals positive or negative 2i. 4 is a perfect square, so it equals positive or negative 2, and then negative on there gives us the I. And then finally subtracting the 10 to make my x all alone, so negative 10 plus or minus 2i. Okay, and then number 16. So number 16, we do have this coefficient here in front of the x squared. So what that means is that I'm going to have to divide everything by that 6 first. Doesn't matter if you get a decimal or anything like that, you still have to do it in order to do completing the square. So I'm going to get x squared plus 14x plus 50 equals 0. Now we can do the same thing we did in the previous two problems. So half of 14 is 7, and 7 squared is 49. So in order for me to add this 49 to both sides, I have to move my 50 over first. Now that I have my 49, I can factor this into the square of a binomial, so x plus 7 squared, and I combine my like terms on the right, and I get negative 1. square rooting both sides. X plus 7 equals positive or negative 1i. Subtract the 7. X equals negative 7 plus or minus I. Okay, so now we're going to do some problems still using completing the square, but for a different purpose. So this time we're going to use completing the square to write the quadratic function in vertex form and then identify that vertex. So for number 17, what I like to do personally is bring that C value to the other side just so I don't get confused with it. And of course, anytime you bring something to the other side, you're always going to change the sign. Then I kind of do that same process where I figure out what do I need to add to each side in order to make this into a perfect square trinomial. So half of 8 is 4 and 4 squared is 16. And now I have x minus 4 as the square of my binomial. And when I combine those two like terms over here on the left, I get negative 15. Now, we're not solving, so we don't have to square root the two sides at this point. We're just simply going to bring that 15 over, back over, so that it looks like it's in vertex form, making sure you change it back to a positive. And then, of course, we can identify our vertex, which would be positive 4 and 15. And if you want to check your work, graph the original on your graphing calculator, then graph your answer, and they should give you the exact same graph. Okay, so number 18 now is a little bit trickier because obviously we have this coefficient. So we're going to have to divide this by 2 first. So when we divide that by 2, the tricky part here is that you can't forget about it. When we solve and we divide by number, we don't really need it again, but when we're putting it in vertex form, we have to account for that number we divided out. So after I divide that out, I'm bringing this 2 here at the end to the other side. And you don't have to actually move it to the other side. I just personally, it gets in my way when it's over here, so I like to get it out. Okay, so 2 divided by 2 is 1, and 1 squared is 1. So that's what we're adding to each side. And then I can write x plus 1 squared is the square of my binomial, and 2 plus 1 is 3. Now at this point, you would probably think, okay, I'm just going to bring my 3 over to the other side, and then I'm going to have y equals x plus 1 squared minus 3. But don't forget, there's that little catch. That 2 has to get multiplied back to both sides. So this now is really a 6 that needs to come over here. So you end up with 2 times x plus 1 squared minus 6. And that's the part that people sometimes forget. So now my vertex is negative 1 and negative 6. And again, it's really good idea to check what you have here and compare it against the original one in standard form on your graphing calculator, because you'll have a nice visual if you got the answer correct or not. If they don't line up, then you know you did something wrong. Okay, so moving on, we had mostly just done, I think, triangles and rectangles in our notes as far as finding dimensions. So this one is a trapezoid one. Now, area of a trapezoid is 1/2 times the height times the sum of the two bases. So if we wanted to fill this in, right? So this is our height. This is one of our bases. This is our other base. And we, of course, we know the area is 70. So I could go ahead and write 70 equals 1/2 times x plus 4 times x plus 3x. Now I can simplify this because x plus 3x is simply 4x. And actually, half of 4x is just 2x. So that will be a little bit easier if I kind of keep working it down from there. Now, one option for solving a problem like this would be to then bring your 70 over and make it standard form, but you don't need to do that. So this is 2x squared plus 8x. Okay, so you have a couple options. You could subtract the 70 over, and then you could attempt to factor it or use quadratic formula. Or since it's kind of looks like it might be set up in some sort of completing the square, we could do that as well. Obviously, the only catch here is that there's that 2, so I'm going to divide it all by 2. So there's really a couple methods for this particular problem on how to solve it. So if you get the answer but you did it a different way, that's totally fine. Okay, so half of 4 is 2, 2 squared is 4. So I have 39 equals, and over here, x plus 2 squared. And then I'm going to square root that. So I ended up with x plus 2 equals the square root of 9. And of course, there's a plus minus there, 39. And I think that just works out to 13 and 3, which is not going to help you. So x equals negative 2 plus or minus square root of 39. Now, if you were to do these on a calculator, okay, to check those answers on the calculator, if you needed a more precise answer, would be negative 2 plus the square root of 39. That would be one answer. And then the other one would be negative 2 minus the square root of 39. So 4.24 and negative 8.24. Now, obviously, the one with the negative is not a solution because you can't have a negative base up here. So if we were to say that x equals negative 2 minus the square root of 39, I think that was the one that it was, right? Yeah. No, negative 2 plus, sorry. 4, that worked out to be 4.24. And I believe that's all it asked us to find there, right? So find the dimensions. So if you were to plug that in, so then you know this is 4.24. This here would be 8.24. And 4.24 times 3, 4.24 times 3 would be 12.72 approximately. Okay, so those would be your dimensions. All right, using quadratic formula to solve the equation. Now, before I do these two, I'm going to go through the discriminant because I think it's really important that we use our discriminant whenever possible to kind of help us with that quadratic formula. So for my discriminant, I'm going to remind us that it's b squared minus 4ac. So this is your a, this is your b, this is your c. So this means I have negative 15 squared minus 4 times a times c. Now, negative 15 squared is going to be positive 225. And then there I have 3 negatives, so that's going to be a negative, and that's going to be 120. And that will equal 105. So this means, since I have a positive answer, I'm going to have 2 real solutions. And those real solutions will be irrational, since this is not a perfect square. But it also tells me I will have 2 visible x-intercepts on my graph. Okay, so let's try the next one. So next one, we have to get everything on one side to do the discriminant. So x squared plus 2x plus 5 equals 0. So I simply moved these to the other side. So now I have a, b, and c, where my a is really 1. So b squared minus 4 times a times c. 4 minus 20 gives me negative 16. So a negative discriminant tells me I'm going to have 2 imaginary solutions. And that also means there will be no visible x-intercepts. Okay, and then we have a third example here. So bringing over that 2, And now I have A, B, and C. So B squared minus 4 times A times C would be 64. And then let's see, I've got 8 times 4, which is 32, times 2, which is 64. And that's 0. And that tells me I will have one real solution. And that means I will have one x-intercept. So that parabola will just touch the x-axis in one location, and that'll be either the min or the maximum of the parabola. Okay, so using that knowledge about our discriminants, let's go back and do these two quadratic formula problems. So for the quadratic formula, right, we have A, B, and C. Now, I would advise you to find the discriminant first because that actually gives you useful information, and it's already got most of your quadratic formula simplified down to a pretty good place to work with. So we have negative 19 squared minus 4 times negative 14 times 3. So my discriminant for this here, you should get 529. So then when we put that into our quadratic formula, we have negative 19 plus or minus the square root of 529 over 2 times A. Now, of course, that simplifies to just 19. 529, the square root of that is very nicely, first of all, it's positive, so we know we're going to have two real solutions. Second of all, it's actually a perfect square. If you square root 529 in your calculator, you're actually going to get 23. And 2 times negative 14 is negative 28. So now we can get our two exact answers. 19 plus 23 is 42, I believe, right? And then we would divide that, and we end up with, I believe, 3 over 2. And 19 minus 23 would be negative 4 over negative 28, which will work out to be 1/7. So those are our two real solutions. Okay, and then number 21, we are going to, again, A, B, and C. I would encourage you to do your discriminant first. So negative 8 squared minus 4 times A times C. So 64, and this is going to be minus, I believe it's 140. And you're going to end up with a negative 76. This tells me I'm going to have two imaginary solutions, right? So I'm already kind of knowing what to expect here. So x equals negative b plus or minus the square root of negative 76 over 2 times a. So when I simplify, I get positive 8 and 2 on the bottom. And 76, I'm actually going to simplify that because the 76, you could break that down. All right, so the square root of 76, let's see, 35 is 38 and 2, and that would work out to 19 and 2. So we're going to have 2i19. Now, the 2's can cancel out, and the 8 over 2 can cancel out. So this is going to be 4 plus or minus I radical 19. Okay, and then we have one more question, and that is going to be our dropped or our thrown object model, because we are using this formula here, which is basically a standard quadratic equation, okay? So using the given formula, we have a few pieces of information here, right? So we have the h, which is the ending height. We have the h sub 0, which is the starting height. And then you have your velocity, which is your speed, right? So it says here, a ball is thrown from a height of 8 feet. So that would be your starting height with an initial velocity of 30 feet per second. And if the ball is caught at a height of 2 feet, so that would be your ending height, how long is the ball in the air? Because the ball was thrown, unless it says it was like thrown downward, we're going to assume it's always kind of thrown a little bit upward, which is why our velocity is positive. So we're just going to put these numbers in where the variables are. So h is going to be 2, negative 16t squared plus 30t plus 8. Now, in order to solve a quadratic, we want it to equal 0, unless you're going to use like completing the square. But with these larger numbers, you're probably not going to want to do that because you divide by 16 and get negatives or decimals. So we're going to actually move that 2 over, make it equal 0. And then we're just going to use our quadratic formula because that's like the best method to use when you have kind of weird numbers. So again, finding that discriminant first. So if I go to find that discriminant, I have 30 squared minus 4 times negative 16 times 6. And I would just go ahead and do that on a calculator. And if you do that on a calculator, I believe you get 1284. So now when you plug in your quadratic formula, you'll have negative 30 plus or minus the square root of 1284 over 2 times a, which will be negative 32. And then you can just calculate those two answers. So the first one, you'll have negative 0.18 when you type that in your calculator. The second one, you'll have 2.06. Obviously, the negative doesn't make sense because you can't have negative time. So your final answer would be 2.06 seconds.